Okay, so again, thank you everybody for joining our presentation this morning. We're going to be talking a little bit about decentralized identity and verified ID, which is the Microsoft Azure implementation of that. My name is Marcus Idle. I run the external identity practice at Cocho. So we've been very closely involved with Microsoft Identity, particularly external identity, for the last few years, and working closely also with Rohit Gulati, who's a principal program manager in this space, and he'll be on in about 30 minutes to help answer questions. So we're going to end the presentation at 12:30, and then we'll have about 10 minutes of questions. So as head of external identity, I also work with B2C and B2B, and I'll give you a little bit of more of an intro to Cocho as a whole in a second. Okay, so just a little bit about Cocho. So we work in the area of identity and security. We're a Microsoft Gold partner in a number of areas, and we're here obviously to help you become greater. So it's all about helping ambitious companies to realize their full potential, trying to understand your vision, and then helping you at all levels to kind of develop that into a strategy and into a transformation journey. As I say, my particular specialty is with external identity, hence why I'm talking about verified ID today. And we'll have a little bit more at the end of the presentation about how you can contact us and get to know more. So what's the problem we're trying to solve here? So there's a few things that people, industry experts, have identified along the way. One of which is when users arrive on a website that offers them a service of some kind, there's often a lot of retyping of information. So essentially, that can lead to a fragmentation of their relationships with external organizations. That can lead to information that's inconsistent. But most of all, it's kind of leaving users not in control of how much of their information is in other people's hands, and how's it being shared, and so on. And that leads on to the second one. Users can often provide information without being in control of it, and where it's going. And when dealing with organizations that have some kind of relationship and granting consent for one to access the information in another, users aren't really in control of that consent. They're just pushing buttons. They don't necessarily understand the relationship between those organizations, and indeed, how much the information is used, when it can be used. They can't revoke it, anything like that. So they may feel like they're not in control. There's a lack of trust. And finally, organizations, if they are going to exchange data, so if you are going to try and bypass getting all the data from the user themselves, if you're going to exchange it with another organization who already know that information about the user, that in itself is complex to set up. So verified ID provides a simpler way, actually technically simpler way of doing this. So taking the information directly from the user, verifying in a simple way that information is correct, and then getting on with using that data. So decentralized identity, as I said, is the solution to some of these problems, and it's a worldwide standard that has been developed by industry experts over the last few years. And as I say, Microsoft's implementation of this is called Verified ID. The system uses a trusted verification system, essentially placing on the public record a record of the issuing of a credential to an individual. So we'll go over that in a second. It puts the user more in control. They can actually decide who to share their information with. They can decide how much information to share. They get a record of who it's shared with, and they can actually revoke it. And it removes unnecessary data exchange. So as I said, you've got two organizations talking to each other. You can actually cut some of this out and get the organizations talking directly to the user. So just to break down some of the concepts we're going to be talking about, we have in the decentralized identity world, we have an issuer. Essentially, that's an organization that knows who the user is. So it may be a university, it may be an employer. Alternatively, it could be, the user could be new to that organization, and what happens then is the organization attests to some claims. So, asks the user to provide some proof of who they are. So this could be, passport, for example. And once that information has been processed, again, the organization knows to some extent who the user is. And so at that point, they can grant a credential. So they can provide the user with a digitally signed credential that can then be used in the rest of the process. Then we've got the individual, obviously, they receive the credential and they can, they store that credential, so it's in their possession, and then they can present it to the verifier in the future if they need to prove that they own that credential for some reason. And then there's the verifier, obviously, an organization that the individual wants to work with or, do business with, and the verifier needs to understand the proof that that credential is true. And given that proof, then it can receive the credential and then process the information. It doesn't collect the data about the user from the public record or from the previous, from the issuer. It collects the data directly from the credential. And then finally, we've got the verifiable data registry. So this is the public record. This stores the proof, like I said, it doesn't store the data, but it stores the proof of issuance of that credential. So Microsoft like to talk about this example, the real world example of an automobile association or roadside rescue company. You might be a member, and if you're a member, then you will have a credential, but that's in the form of a plastic card, for example, in your real world wallet. Of course, if you're a member of that organization, they will know about you. So they have there is a public record. You could call up the call center and say, well, do you know so-and-so is a member, and they can give you an answer. So then if as somebody whose car has broken down or whatever, I can go to a garage and say, this is my card, this is my membership card, and they will recognize that card. And if necessary, they can actually call up the call center and say, is this person a member? So how does that break down in the digital world? Again, you have roadside rescue, but instead of a plastic card, you have a signed verifiable ID, and you store a record of that, a signed record of that, in the blockchain. So it's a public record. It's easily, the verifier can easily look it up. And of course, the garage is the verifier in this case, and you can present this digital ID, and they will look it up, look up the signed proof in the blockchain. So where does Microsoft fit in? So you may, hopefully you're aware of Microsoft Entra now, which is a kind of blanket term for some of the identity services that Microsoft provides. So that includes Azure Active Directory, including B2B and B2C, permissions management, which is a fairly new component, all about identity governance, and in this case, verified ID. So the verified ID service on Azure provides you with the ability to generate credentials and an API which creates QR codes, which we'll look at in a second. Microsoft provides some sample code to interact with the Verified ID service. So you can build a verifier website. You can also build an issuer website, and again, we'll show you that working in a second. And also the Authenticator app. So this is your digital wallet. So this basically answers the question: does the consumer actually know what's happening? You know, I posed the problem when I started talking about decentralized identity. You know, that the user really doesn't feel in control. Is this any different? Yes, because what's happening is you're using the Microsoft Authenticator app. It could be another component, obviously, because decentralized ID is standards based. But in this case, we're using the Microsoft Authenticator app, which obviously many of you will have on your smartphones in your pockets right now, to store these credentials. So it's a feature that's been part of this app for a little while now, and I'll show it in action. So then the user can see the credential. It's all, you know, it's almost a physical thing, and they can also use the app to see where that credential has been, and they can decide who to give the credential to, and so on. So that's all well and good. That's all about the consumer. How does it help us as, you know, organizations? What does it do for us? So for a start, obviously, when you're providing the user with that level of control and trust, that makes it easier for them to engage with you. But it's not just about that. It's about actually breaking down this information exchange. And as I hinted earlier, obviously, it's easier for an organization to take those claims from the credential and look up on the blockchain to see if it's verified. That's an easier piece of work than creating you know, these complex inter-organizational relationships, calling APIs to grab user data, and doing something on the verifier end to you know, to prove that they have you know, they should have access to these APIs and so on. So it's actually a simpler process for the organization. And here I'm presenting just a few use cases, and we'll also present one in the demo as well. So here we've got an employer who is the verifier over on the right. They are they require their employees, or a certain portion of their employees, to have a university degree. So what's happening here is the university degree is issued as a verifiable credential into the user's wallet, digital wallet, by the university, so that the employer can then grab this data, make sure it's valid, and then there's no, you know, the employer has no data exchange with the university itself. Another example could be an employee benefits portal. So here the employer is actually the issuer. You have an employee. You've already got this relationship with an employee, but you're providing some employee benefits, which is a separate company, a separate website. How does the employee benefits portal know that you're an employee of that employer? You can have a digital card that says you're an employee, and obviously present it to the benefits portal. Another example could be a civil aviation authority or some authority like that, where you have to have a medical certificate before you can renew your pilot's license. So in this case, the NHS or you know, whoever's responsible for performing that medical exam can issue a certificate, and again, the pilot can present that on their digital wallet to the aviation authority. So let's see a demo, which is a separate use case in itself. This is going to be just a simple identity verification, but using a photo and a passport. So those parts will be glossed over. That's not the point of the demo. But once the photo and the passport have been verified, the organization doing that verification can issue a credential, and then that credential can be presented to the employer when the user wants to complete onboarding. So the employer can be in a good position to say, yes, I know who that user is. So this is actually a demo on the Microsoft website. There's a link in a slide later on, so you can try this for yourself. So like I said, the employer is the verifier, but the issuer is a company called True Identity. So we're going to go to their website first and do this passport verification. So we're going to upload our government ID. We're going to take a selfie, and we're just going to pretend that this was all fine. So then we know who this person is. We know their first name and last name in this case. So at this point, the issuer presents a QR code. And what happens is, so this QR code will provide the Microsoft Authenticator app with the actual credential. So we need to open up our Authenticator app. As you can see here, we need to unlock the screen, and then we need to just click here, Verified ID, scan a QR code, and the phone's already pointed at the screen. So we have one final step, which is to enter a PIN, and then we can store the card. So we're going to punch in 5524, hit next, and it says, do you want to add this? So again, users in control. So that's all done. So now we're going to return to the employer, in other words, the verifier. Well, first of all, it says confirm you have your card. Yes, we have our card. But now we have a QR code, which is, this is the verifier. This is Woodgrove saying, can you please present your credential? So you scan a QR code to present the credential as well. That's all good. So the employee can continue onboarding. So we decided we would do our own demo. So in this case, we're going to be the issuer and the verifier. We're going to say, if you sign up for an event, for a co-chair event like this webinar, or our summit, which I'll talk about, you can store those details that you yourself put in. So it's kind of self-certification. You can put in first name, last name, email, and so on. Store that in it as a card in your digital wallet, and then you can present it back when you want to register for another event. So it's basically just saving you a bit of typing and illustrating verifiable credentials at the same time. So Microsoft provides, like I said, a sort of a set of code libraries. So you can get this from GitHub. And we've created a web page saying co-chair event sign up by verifiable credentials. And there's a bunch of libraries here that help exchange exchange information between the application and Microsoft Entra Verified ID. So there's an API which provides the QR code and so on. So here in Verified ID, so in Azure, we have our Verified ID set up. And also note, so if you want to create a credential, we created a custom credential, but Microsoft are working on a few things here. So educational credentials for staff and students, and they've already got an employee credential. So these are kind of templates that you can use to get you set up even more quickly. So we've got our credential here, which is just co-chair event attendee, and it looks like that. And so we obviously built the website based on the code from GitHub, and made some changes to make it look a little bit more like CodeCheck. And so we have it here. So we're just entering our information for the first time, because obviously the first time you come in, it doesn't know who you are. But then we're going to hit register, and as well as saying thank you for registering, it's going to provide you with a QR code. So that's the QR code to receive the credential, and then if we hit sign in with VC, then it'll present a QR code for presenting that credential again next time you want to sign up on this website. So that was just just a brief demo to show you how easy it is to build verified ID websites, and B, to interact with verified ID as a consumer with the Microsoft Authenticator app to store those digital credentials. This is the demo link. So this is where you can go to that Woodgrove demo, the employee identity verification demo. Before we get to questions, I just want to share with you a couple of things that you might be interested in, especially if you think that verified ID is relevant now or in the future. So we can, with Microsoft, provide a proof of concept. So a simple proof of concept for verified ID that's kind of matched to your organization, so to your requirements. So please do get in touch with one of the sales team if you think that would be useful for you. The other one is an identity workshop. So this is more of a kind of exploring external identity as a whole. Maybe you're interested in B2B verified ID, a mixture of some of them. Again, please do get in touch, and we can set up a scoping call with one of our sales team, one of our technical people, to figure out what's best for you. The other thing I just wanted to share, if you want to know about any of these subjects or anything else that we do as a business, and Rohit, who's here answering questions, will be at this event talking about verified ID in a bit more depth, and we've got a lot of other topics obviously that we're going to cover. So this is our Identity Security and Compliance Summit. We've had them every year, and this is the first in-person event since the pandemic, so we're very much looking forward to this. As it says, there'll be 10 industry-leading keynotes, 20 workshops, so there's a lot to choose from. So please do get your name down for this. So it's absolutely free to attend, and it's such a useful event to kind of understand the latest and greatest technology from Microsoft, and also obviously what we and or our partners can do for you. Okay, so we're going to go to questions now. So please do type your questions in the GoToWebinar panel, and as I said, Rohit and I will be able to answer them. So I'll just give you a second. So, excuse me, just got a question. What are the licensing requirements, or is it Azure consumption / marketplace based? I think I might wait for Rohit to come on for that one.
Sure. Hi.
Here we go. Thank you.
Thank you, Marcus, for inviting me to this webinar. So Verified ID is part of all Azure AD SKUs. What I mean by that, even if the customer is using Azure AD free, verified ID is available for that customer. As you start using verified ID along with P1 and P2 features in future, then you may use the P1 or P2 subscription capabilities. So to keep it very simple, the verified ID service requires uh, a directory instance that could be Azure AD free as well. It needs Key Vault. So Key Vault will be an Azure resource that will be used as a part of onboarding the service, issuing credentials, verifying credentials, because you can imagine this is a cryptographic handshake. We need to store, assign, update, and manage the recovery keys. So we use Key Vault. And as you look at this particular solution, you may choose to integrate it with your existing app, or you may want to build your own apps like what you just saw in the demo. A demo site or a registration site was built on Azure App Service, so that could be another component you may need to think of as you plan. So verified ID, part of any Azure AD SKU. Key Vault is part of the Azure consumption model. If you are building new apps, then you could use services like Azure App Service for it.
Fantastic, thank you, Rohit. So there's another question. Are there any real world cases where verified ID is already in use?
Yeah, so we have got 6 public case studies on our documentation and marketing site. So if you browse to aka.ms/verify once, you will see those 6 references. In England, in UK, we have NHS using a verified ID for staff passport scenarios. The Blackpool Teaching Hospital case study talks about the current issue they had, where a doctor had to every Monday they have to sign up, they have to go through this admin process of registration, they have to prove who they are, they have to get their credentials validated so that they can practice or do a surgery or on an operation. So they are using it for staff passport scenarios. Then we have a few organization using it for visitor management system. An organization is using it for skills management and training credentials. Like when I complete a training, I can get that as a credential, and then I can prove to an application, yes, I am up to date in terms of credential, so that the application allows the user access in for critical access scenarios. And then there are a few around a government to citizen scenarios. A Flemish government is using it for users to supply attested data as they look for citizen services. So there are 6 such cases. I just did a quick summary. Please go to our public site and you can see those references.
Cool, thank you, Rohit. There's another question. Can you put up the architectural component slides? So not sure if you mean this one, Dave. Please do pop another question if you didn't mean this. What does the permissions component do? That was another question from the same person. Not sure what's meant by the permissions component. Do you, Rohit?
It's a very
Not that one with the box.
yeah.
Go ahead.
So maybe I'm missing the relevance of the question, but I'll take a stab at it. See, if it is if that question is related to this diagram, um, and it is like what is the permission model for the bottom layer, which is the ledger, the implementation that we have done. Sorry, Marcus.
Okay, carry on answering because it might be relevant, but I've got another question. It's about the Entra as a whole. But if you want to just finish up what you're saying, Rohit, sorry.
Okay, yeah. So what I was trying to say, if you look at the flow diagram here, the component on the left, the roadside rescue entity, is issuing a credential, and there is a downward arrow where the public key material goes to a ledger. You may ask questions like the ledger that could be a permissioned ledger or a non-permissioned ledger, a permissionless ledger. What Microsoft implementation offers today. So today we offer a permissionless model with IAM, and you could also think of like a permission model with web. So the public key material that you store, that could be on blockchain, it may not be on blockchain, but the relevance here is it is available for the verifiers like Garage to consume that material. When you host it on your website, the security model that you have on your website controls that permission boundary. But if you store it in elements like blockchain, our implementation is permissionless, which means you can run a you can run a node in your data center. You can do referrals from any other node that is running elsewhere as well. So if the yeah, I just took that permission question keeping this diagram in mind, but I'm just trying to present a view. The bottom layer could be blockchain, it could be non-blockchain. You can choose which model you want to go with. Microsoft as a platform offers both models.
Okay, thank you, Rohit. That's great. Yeah, sorry, Dave. I tried to unmute you, but it doesn't seem to be working. But I got your question about this diagram. So yeah, verified ID is what we're talking about today. Permissions management used to be Cloud Knox. It's basically like a component now of the overall sort of identity governance, identity management service that Azure provides. So it's about making sure that you don't get threats from your internal users, your guest users, and also across. It works across clouds. So you can put in data from sources outside Microsoft essentially. So that's what permissions management. But we will have more on permissions management in our summit, and we will also be doing a webinar very shortly on permissions management as well. So please stay tuned for that. Okay, to see if we've got any more questions. So just one other question right now, Rohit. So what happens when information about a user changes or needs to be revoked? How does Verified ID cope with that?
Sure, Marcus. So I'll answer this question keeping the statement in two parts. So let's say there is some malicious activity that has happened, and as a issuer, you may want to revoke a credential. Uh, it could be for any reason or scenario. Uh, See, this whole principle is based on privacy preserving model. What I mean by privacy preserving, when an issuer has issued a credential to the user, uh, issuer should not track where the user is presenting this credential. Keeping that construct in mind, and if I need to do a revoke activity, how I can make sure both things tie up together. So when I am issuing a credential to a user, I do have a model to make sure that one of the attributes that are part of the credential, I create a index hash of it. So that becomes a enabler for me to do a revoke command in case I need to do any admin activity. So as an issuer, if there is a malicious thing or I need to do a revoke task, I'd use that index value to do a search of what I had issued to the user in the past. And there is a standard called as VC status list 2021, which makes sure that privacy preserving model is maintained. So as an issuer, I just make sure that whatever I've issued, I will flip the bit from 0 to 1, which means that's a revoke credential. Now, when a user goes and presents a credential, every time a verifier would check, is the user giving me an active credential or revoke credential? As a part of that check, if the verifier sees if the binary bit is 1, that means it is a revoke credential. So I'm trying to talk about a complex concept in just 2 minutes, but think of it like a privacy preserving model, issuer make sure there is an index hash available. It uses that string to issue a revoke by flipping the binary bit. And the user, when the user goes to present, a verifier would check the status of that bit. Is it 0 and 1? That way there is no tracking, but still making sure that the revoke process happens if there is a business need. So that's revoke. But let's say if there is an attribute change that has happened, let's say my middle name has changed or my last name has changed, which is a very common pattern, right? What we do today in our physical world, let's say if there's a last name change, I may go to the issuing authority to give me back a new passport or a new credit card. In the current model, that's how we do verifiable credentials as well. So if there is an attribute change, the user can be told to get back and get a new VC. But we are exploring options where can we refresh a VC based on this particular requirement? Like if there's an attribute that has changed, can I just do a refresh of a VC? So that concept and that work is still work in progress. We are not making anything proprietary. We are following the open standard. So as we look at the open standard, how a refresh VC should work, we will implement that in future. But today, if there is an attribute change, user is told to go back to an issuer to get a new VC that has that refresh attribute available in it.
Thank you, Rohit. We are running out of time, but I want to squeeze in two more questions if you don't mind keeping it brief. So we've got one: if the user lost their credential, e.g., if the device with the MS Authenticator was reset, can they be recovered? So that's one.
Yeah. So we offer backup and restore option in Authenticator app. It allows the user to recover a credential, or they can also use this backup and restore model if they move from, let's say, Android to iPhone or vice versa. So Authenticator app has this capability of backup and restore.
Okay, fantastic. And finally, as a verifier, what components does the verifier need to have?
So as I said, this is a cryptographic handshake. Verifier would need an instance of the verified ID service and key vault as well, because when I am accepting a credential or am throwing a challenge to the user, hey user, I can only offer you discount when you show me a verified employee credential. These handshakes are also signed handshake, cryptographically signed handshakes. So you need an instance of verified ID service and key vault. You could always start with Azure AD Freescale. That way you are bootstrapped and you need a key vault instance to store the keys for these sign and response models.
Okay, fantastic. Well, thanks so much for joining the call, Rohit, and thanks for your time. I do see that there are other questions on the panel. We'll try and answer those separately, but I will close the call now. Thank you very much for attending, everyone. And as I said, please do get in touch if you do want to be part of a POC or indeed part of our summit, where we're going to dive into a lot more detail on a lot of these topics. So thank you very much and have a nice day.
Thank you all.